Hello guys, I Rakesh Talreja welcome you all to BYJU'S exam prep. It's the festival time. Happy Dashara to all of you. Happy Vijay Dashmi. But a holiday, a gate aspirant, like a soldier is never on holiday, a true gate aspirant, especially in the last 4 months, is never on holiday. So on this holiday, what is important? What is important for aspirant? To utilize more and more practice and to enhance to your practice level. Today, me and Sanjay Rathi sir are bringing you the mini mock test. So mini mock test as in, the topics, the areas which are common to both electronics, electrical students, like electromagnetic field theory. EMFT also will be taking those topics which are common to both. Okay, engineering mathematics, signal and system control system, digital circuits, network theory, and the analog circuits. Okay, since it is mini mock, okay, what variety it is going to contain, let me give you the idea of that as well. Okay, so like regular gate paper has 65 questions. Today you are going to encounter 30 questions. Today you are going to encounter 30 questions. Okay, there will be the 10 questions for 1 mark. Okay, there will be the 20 question for 2 marks, and the total marks is going to be 50. Okay, so mini mock, out of 100, rather than 100, you are getting out of 50. Okay, so of course, aptitude we have not included because aptitude you keep doing a lot of practice and other sessions also we keep giving you. But let us focus on the other parts: signals, control, digital, network, analog, EMFT, maths in this session. Let's get started quickly. Okay, so I will be taking, in this mock test, I'll be covering the questions from maths, signal and system, control systems, and EMFT. Okay, and Sanjay Rathi sir will take up the questions from digital, network, and analog circuits, right? So let's get started. The first question, before the first question, let me tell you that the complete PDF, okay, along with the questions, along with the solutions, you will be getting in my Telegram group. Okay, and other than that, the important doubts, the daily doses, and updates about examination for multiple things, you can be connected in my Telegram group. Okay, so please, you can join it. The link has been mentioned here. So now this is the first question, guys, and we will be taking exactly gate variety question. Like that means it can be MSQ, MCQ, NET, anything. Okay, 1 mark MSQ question. Okay, starting with engineering mathematics, because maths is an area where MSQs are definitely expected, isn't it, guys? All right, so this is the first question. Okay, if M is k minus 1, 1 by k, 1 upon k minus 1, and modulus of mk is the determinant of the matrix mk, okay, depending on k, then find the value of the summation, that is mod m2 plus mod m3, etc. up to the mod n. Okay, and choose the correct answer. Okay, choose the correct answer. First of all, what is the mod mk? Okay, mod mk, a slight cross 2 slight cross multiplication, k into 1 minus k minus 1 whole square, so 1 upon k minus 1 minus cross multiplication 1 by k. Simple now. Okay, that is what is the value of mod k. Okay, now let us complete the summation. So what is going to be the value of the summation? The summation is modulus of m2 plus modulus of m3 plus modulus of m4 also, etc. up to the last term modulus of mn. So what is the modulus of m2? See, if you talk about k, 1 upon k minus 1 minus 1 upon k, so k ka value agar 2 rakha, okay, so you are going to get 1 upon 2 minus 1, so 1 upon 1 minus 1 upon 2. What should be the next term? If you place 3, so 3 minus 1, 2, so 1 by 2 minus 1 by 3. 1 by 2 minus 1 by 3. Of course, next, okay, for k equal to 4, 1 by 3 minus 1 by 4, etc. Okay, last term will be 1 upon n minus 1 minus 1 upon n. So what you are able to feel is that, minus 1 by 2 plus 1 by 2 cancelled, minus 1 by 3 plus 1 by 3. Okay, so for every particular term, the second component will cancel the first component of the next term. Okay, so here this first component will cancel with something that I have not written here, but this will not cancel, because for this to cancel, there has to be next term, and there is no next term. This is the last term. Okay, so what is the value of Sn? 1 minus 1 by n. Okay, what is the value of Sn is 1 minus 1 by n. Okay, agar n ka value 2 hai, right? If the n is equal to 2, then the Sn is 0.5. Okay, n is equal to 2, the Sn is equal to 1 minus 1 by 2, correct, 0.5. Okay, and I need to check for n equal to 5 and n tending to infinity. Okay, so if n is equal to 5, what is the value of Sn? 1 minus 1 by 5, that should be 0.8, correct. Okay, and for n tending to infinity, okay, what is the value of Sn? 1 minus 1 upon infinity tending to 0, so it should be the 1. Okay, so now let us match the options. Okay, for n equal to 2, it is 0.5, correct answer. Okay, for n equal to 5, it is 0.8, that is also correct. Okay, so ये गलत हो गया, n equal to 2 वाला, and n tending to infinity, it is 1. Okay, थोड़ा सा इसको ऊपर कर देते हैं. Yes. So for n tending to infinity, it is 1. Correct answer. So A, B, D. The correct answer for the multiple select question is A, B, D. This is the first question. 1 mark MSQ. Let us move to the next question coming up here. Okay. The PDF. Okay, the probability density function A e power minus B mod x, where x is a random variable, okay, whose allowable range is minus infinity to plus infinity, that is complete values of x. What is the CDF for this function? Okay, what is the cumulative density function for this? So how do we find out the CDF? Suppose the CDF is given by the function gx, and that is given by integral minus infinity say x fx dx. Okay, integral minus infinity say accumulation of all the probability up to the x. 2 marks MCQ question this is. Okay, so what is going to be the gx? Okay, that is integral minus infinity say x. Okay, place down the value of fx, that is a e raised to the power minus b mod x dx. Okay, so now this is equal to integral minus infinity say 0. Okay, because modulus function is there, so I have to break, okay, according to positive or negative limit. Okay, minus infinity say 0, a e raised to the power a e power minus b. For negative limit, mod x is minus x. For negative value of x, mod x is equal to minus x. Okay. Okay. Plus integral 0 to x. Integral 0 to x a e raised to the power minus bx. A e raised to the power minus bx. Okay. Okay, so we are treating it for all values of x. Okay, of course I have treated x positive here. Of course I have treated x positive. If x is not positive, तब भी कुछ हो सकता है क्या? We can discuss that. Okay, so first let me complete this integration. Okay, so g of x is turning out to be how much? Integration minus infinity से 0, minus infinity से 0, a e power plus bx हो गया. Correct? a e power plus bx dx. And next integration is integration 0 से लेके x. 0 to x a e power minus bx dx. Okay, so what is this answer? A e raised to the power bx, a e power bx ka integral a e power bx divided by b, limit minus infinity se 0. Next is a e power minus bx divided by the value of minus b. Okay, limit 0 to leke x. Okay, so this is going to become, okay, a by b. तो कांस्टेंट है, अपर लिमिट e पावर 0 1, लोअर लिमिट e पावर माइनस इंफिनिटी दैट इज 0. ओके, प्लस a अपॉन माइनस b here. Okay, upper limit e power minus bx only, lower limit is 1. Okay, so finally what I am getting is, okay, a by b, right? Okay, plus ये हो जाएगा actually minus a by b e power minus bx. Okay, this will be minus minus plus, so one more a by b, so 2a by b. Okay, so it should be a by b. Okay, 2 minus e power minus bx. Okay, option number b. But a point to be noted here is, okay, एक बार थोड़ा सा डिस्कस कर लेंगे इसको. Suppose if the a was negative, sorry, not a, suppose if the x was negative only. So if the x is negative, okay, gx is integral minus infinity से x, a e power minus b mod x, and x is negative, मतलब the entire range is only negative, need not split, but mod x is equal to minus x. So this is a e power plus bx, and integral is e power bx divided by the value of b. Okay, that is minus infinity से लेके x. So the answer is a by b e raised to the power bx, upper limit, lower limit is e power minus infinity, that will be the 0. Okay, a by b e power bx. So there has to be second case also. Of course, our option will match. Okay, of course, our option is going to match here. No doubt in that. Okay, your option will match. Okay, but the CDF for this function for x greater than 0. But generally, I am telling you. Okay, generally, I am telling you what you are given is, okay, what you are given is x greater than equal to 0, and accordingly, I have solved this. Okay, but if x is less than 0, what should be the result? But if x is less than equal to 0, what should be the result? ये भी मैंने बता दिया है in case they ask the complete CDF. Done है? Third question, guys. Okay, if fz is equal to summation z power n, okay, from n equal to 0 to 4, then the residue at z equal to minus I of the function fz upon z plus I power 4. So what is the actual function fz? Fz, summation 0 to 4. So z power 0, 1. Okay, then z power 1, then z square, then z cube, then z power 4 up to the 4 divided by z plus I, okay, power 4. Now you need to calculate the residue at z equal to I and z equal to I, minus I, of course, because that is a pole, and that is a pole of what order? That is a pole of order 4. Pole of order 4, fourth order pole. It's not a simple pole. So residue should be given by what formula? Residue should be given by the formula. This is fz, na? Okay, this is like fz. Okay, this is fz divided by the pole term z minus a power m. Okay, so residue is given by m minus 1th derivative of the numerator function fm minus 1 at the point A, okay, divided by factorial m minus 1. Okay, so m का value 4 है, so we need f3a. Okay, f3a, a means the value of pole and pole is minus I, so I need f3 minus I divided by factorial 3. ठीक है, f3 minus I divided by the factorial of 3. चलते हैं अब. Okay, so what should be the residue? What should be the value of the residue? f3 minus I divided by the factorial 3. क्या करें? f3 minus I divided by the value of factorial 3. So remember, f3 is not f cube, that is third derivative. So we have the fz. Okay, let us calculate the derivative first. We have the fz 1 plus z square, z cube, z power 4. So what is f1? Okay, 1, 2z, 3z square, 4z cube. Okay, what is f2? Second derivative. Okay, 2. Okay, 3 2s are 6z, 4 3s are 12z square. What is the third derivative? Okay, that is 6 and 24z. Okay, so what is the value of the residue now? Okay, residue will be equal to, okay, f3 at the point minus I divided by factorial 3. This is what was written. So 6 plus 24 at z equal to minus I will place divided by 6. 6 ko cancel kiya, so this will be 1 and this will be 4. 1 minus 4i. All right. Okay, 1 minus 4i. That is the answer. That is option number C. Option number C. Hope you are getting it correct. What you can also do is, because I'm putting the question and putting the answer, what you can also do is, whenever I give a question, because you can also take it as a mock test, it's actually mock, you can pause the video, solve it up, okay, and then start looking into the solution. If you are able to get the same answer, well and good, balle balle. Otherwise you can match your answers, you can match the solution, what went wrong for you. Okay, fourth question from mathematics. Okay, integration I have taken this time because sometimes integral questions also do come up. 2 marks MCQ question again. Integral sine power 8 minus cos power 8 upon 1 minus 2 sine square cos square. It is more based on identity and then integration. Okay, so let us take this integral. So this is going to be integrated. Now first of all, okay, a square minus b square, sine power 4 square, cos power 4 square, a square minus b square, if you break, it can be broken as sine power 4x minus cos power 4x is multiplied by sine power 4x plus cos power 4x divided by 1 minus 2 sine square cos square. dx. Okay, acha. Now this is equal to a square minus b square. Okay, that is again going to be a minus b. Okay, that is sine square minus cos square into sine square plus cos square is multiplied by, now let us try to manipulate this a little bit, sine power 4x plus cos power 4x. Dekho, here sine square plus cos square, now you're getting the hint. You can put it as 1. Okay, sine square minus cos square, you can relate with cos 2 theta. But sine power 4 plus cos power 4, ko, convert karne ke liye what you can do is add 2 sine square cos square, add 2 sine square cos square, subtract 2 sine square cos square. Okay. Now divide by 1 minus 2 sine square cos square x. Okay. Now dear, what is sine square x plus cos square x? Ye 1 ho gaya. Okay. And now, what about this part? Let me solve it up separately here. This particular portion is how much? This particular portion. Okay, this is sine square x plus cos square x whole square, a plus b whole square, a square plus b square plus 2ab. So this is like a plus b, that is sine square x plus cos square x ka whole square. Okay, that is further 1 again. Okay, which is further going to be 1. No doubt in that. Okay, so let me place the answer then. This is going to become, this what is left is sine square minus cos square. Acha, what is sine square minus cos square? See, cos square theta minus sine square theta. Okay, that is cos 2 theta. So this will be minus cos 2 theta. Okay, so I have minus cos 2 theta. Okay, the second term is 1. Okay, and then inside the bracket 1 minus 2 sine square x cos square x is divided by 1 minus 2 Sine square cos square x dx. Okay, so 1 minus 2 sine square cos square eventually cancelled. You are left with the simple integration. Okay, that is minus integral cos 2x dx. Okay, what is the integral cos 2x? Sine 2x by 2. Okay, so sine 2x by 2 plus indefinite integral है तो constant of integration. So minus of 1 by 2 sine 2x. Arey, just a second, what happened to this? This is it. Minus of 1 by 2 sine 2x, B should be the correct answer. Okay, done. Next question. Okay, so I presented 4 questions from maths. Okay, so if I summarize, from maths, I took 1 question of 1 mark, that was MSQ, and 3 questions were taken for 2 marks. Total 7 marks have been covered from engineering mathematics, and this particular 1 question was the MSQ also. Okay, now moving to the signal and system, again starting with a 1 mark MSQ question. Okay, a discrete time system Hz is defined to you. Okay, Z plus half, Z plus 1 by 3 divided by Z plus 2, Z plus 3. Which of the following statement is or are correct? Okay, Hz represents an all-pass system. Hz represents a minimum phase system. Hz is stable only when impulse response is two-sided, and Hz is stable when the impulse response is non-causal. Okay, you have to tell me which of them is correct. Okay, so first of all, minimum phase या all pass के लिए, okay, we need to know the poles and zeros. Okay, so what are the zeros here? Okay, what are the zeros? Okay, minus 1 by 2, minus 1 by 3. At the same time, what are the poles? Okay, minus 2 and minus 3. Okay, poles and zeros are symmetric with respect to unit circle. Okay, with respect to unit circle. Unit circle is mod z equal to 1. Okay, so this is 1 into 2, this is 1 divided by 2. This is 1 into 3, 1 divided by 3. So poles and zeros are symmetric with respect to okay, with respect to what? Unit circle. And whenever poles and zeros are symmetric with unit circle, it is a all-pass system. Correct. It is all-pass system. In the continuous domain, we see the symmetry with respect to imaginary axis. In discrete domain, we see with respect to unit circle. Whether it is a minimum phase, all poles and zeros inside the unit circle. Okay, this poles outside unit circle. Outside unit circle. Okay, so that makes the system unstable also, and at the same time non-minimum phase also. It is minimum phase, false. Okay, it is stable when impulse response is two-sided. Okay, achha, sorry, it is not causal. Na? Sorry, let me not comment on unstable because they have not mentioned causal. Okay, so this is non-minimum phase. Okay, so now when it is stable, we can talk about stability. Okay, we can still make it stable because the poles lying inside unit circle is the combined condition of stability and causality. Okay, so causal to mentioned nahi hai. Okay, but what you can do is still you can make the system. What is the condition for stability? Dear, what is the condition for stability? The only condition for stability is that ROC should include unit circle. Okay, right. The ROC should include unit circle. Okay, now there are two poles. What is the possible ROC to include unit circle? Okay, either you can take mod Z greater than 3, greater than the greatest pole, or mod Z less than 2, or mod Z between 2 and 3. But you want unit circle. Okay, so mod Z less than 2. Okay, so ROC to be selected is mod Z less than 2. Okay, mod Z less than 2. So can the system, be two-sided? Okay, no. Two-sided means mod Z between 2 से 3. So system is stable when the impulse response is non-causal. ये true हो जाएगा. This is false. Okay, this will be actually anti-causal. Anti-causal is a type of non-causal only. Okay, so the D is true. So A and D. The correct answer for MSQ is A and D. Okay, it will be stable when the impulse response is non-causal. Okay, impulse response is non-causal but not two-sided. Okay, non-causal, and we can actually mention anti-causal also, strictly anti-causal. Next one, sixth one here, a 2 marks MCQ question on the basic analysis of energy. Okay, but on the even and odd part. A signal xt has xct plus xot. We break a signal into, decompose a signal into even and odd symmetric parts. Okay, so where xe, xo are the even and odd components respectively, and this has a total energy of E. Okay, the signal has a total energy of E. If EE represents the energy of even part, EO represents the energy of odd part, then choose the correct option. What is the relation E0 by EI? Okay, whether it is 1, whether greater than 1, greater than equal to 1, less than 1, whatever it is. Okay, whatever it is. ये हमें check करना पड़ेगा. Okay, ये हमें check करना पड़ेगा. Okay. That is what we need to check. So now guys, come to this picture. Okay, come to this picture. Okay. So we need to compare whose energy is more actually. Okay, and xt energy is known to me. Okay, अगर मैं in general picture की बात करूं, okay, dear, in general, suppose a rough example let me take. This is the signal xt. Okay, suppose this is some signal xt at random, and this has the energy E. This has some energy content E. Okay, what is going to be XE and XO? If you understand this, na? What is the XE and XO? For XE and XO, you also need X minus T. So what will be its mirror image, dear? Okay, what will be its mirror image? Okay, suppose this is going to through, this was -1. Okay, example liya just, so this will start from -3 and end up to 1 now. Something like this. Iska mirror image le liya. Okay, take the mirror image of it. Okay, now. Okay, now. Tell me. ठीक है. अच्छा, if you want to keep it simple, थोड़ा सा और help कर देता हूँ मैं आपको. If you want to keep it simple, what you can also do is, let me explain you this way. It will be a little bit more clear. Let us take a rect of height 1. Okay, so that it can be simple for you. Now take its folded version, X minus T. Okay, so this has some energy, and what is the energy of a rect? Amplitude square into the width. Okay, the total width is 4, so energy is 4. Now when you fold it, okay, it will go from -3 to 1 having the same amplitude. So dear, what is the XET? What is the XET? And what is the XOT? बना लेंगे ना? What is the XET and what is the XOT? Tell me. XE and XO, क्या होगा? Okay, even symmetric part. What is the even symmetric part formula, guys? Come on. It is XT plus X minus T whole divided by 2. तो इन दोनों को add करते हैं correspondingly. Okay, so when you add, the addition will start from -3. -3 to -1, it will be 1. Between -1 to 1, both are 1. So 1 plus 1, 2. Okay, 1 plus 1, 2. Okay, and then between 1 to 3, again, it's going to be 1. But xt plus x minus t whole divided by 2. Okay, whole divided by 2. So ये कितना आ गया? This will be 1 by 2. This will be 1 by 2. Okay, and this is going to be 2 by 2. This is 1. So what is the energy of this signal? What is the EE? Now can we relate? Okay, first amplitude square 1 by 2 ka square, okay, is multiplied by 2. Okay, is multiplied by 2, the duration 2. Okay, okay, then next portion, amplitude square 1 ka square is multiplied by duration, which is again 2. Next, 1 by 2 ka square again multiplied by duration 2. So what is the EE, energy of the E signal? Okay, that is going to be 1 by 4 into 2, 1 by 2, ye bhi hua 1 by 2, 1 by 2 plus 1 by 2, 1 plus 2, 3. This part is 3. This part is 3. Okay, now if you come to the odd symmetric part, okay, xt minus x minus t. So between -3 से -1, ये 0 है, ये 1 है, 0 minus 1, this will be negative. Okay, this is going to be negative up to the -1. Between -1 to 1, both are 1, so 1 minus 1, 0. Okay, and from 1 to 3, okay, xt minus x minus t. So this is 1, this is 0, 1 minus 0 is 1. Okay, but then whole divide by 2. That is not 1, 1 by 2, and this will be minus 1 by 2. Done. Ab batao. What is the EE? What is the E naught actually? This is going to be amplitude square. So doesn't matter. Minus, it is very clear that this energy is going to be less. Okay, minus 1 by 2 ka square. Okay, into the duration. Okay, plus 1 by 2 ka square into the duration. Okay, so 1 by 4 into 2. 1 by 2 plus 1 by 2. This is 1. Okay, this is going to be how much? This is going to be 1. Okay, so clearly energy of E greater than energy of O. Okay, लेकिन यहाँ पे there is one more point. Okay, what is one more point? Whether it is greater than or equal to. Can it be equal also? Can it be equal also? Can it be equal also? The energy of even and odd symmetric part. Can it be equal also? Worst case. See, if you take a signal which was only towards the right, यहीं पर roughly बताता हूँ. Okay, I took a signal which was extending on both the sides. But if you suppose took a causal signal, okay, so when you take the mirror image, okay, the mirror image is only on the left. Okay, the mirror image is only on the left. Okay. Now when you calculate the energy, see what happened, how actually this was more. This was more because, okay, they had the common portion that was added. If they don't have any common portion, this is xt, this is x minus t. Okay, so energy and xo minus t is negative ho jayega, but even if you take the negative amplitude, energy is not affected. The energy is amplitude square. So then it will be same. Then it will be same. Okay, so the correct option will be option number D. Correct answer will be option number D. ठीक है? Let me mention that point if you are confused. Okay, कि if xt equal to 0 for t less than 0, मतलब अगर वो केवल right side में ही है, if that is only on the right side, then EE will be equal to the E naught. Okay, then even symmetric pod, odd symmetric pod have the equal energy. They'll have the equal energy. Done है? Cool? Okay, so okay, then we shall move ahead to the next question. This was a 2 marks, but a good analysis. It gave us some insights about the even and odd symmetric parts. Now, given the signal xt has the Fourier transform sinc x, what is the Fourier transform of the signal yt? Yt is given, but what is the xt? It's not given. Its Fourier transform is given. Sinc or sampling. Whose Fourier transform is sinc or sampling? Rectangle. Try to recall the very important result. Whose Fourier transform is sinc or sampling? Rect. You can remember it in both the format. Rect t by t has the Fourier transform t sampling omega t by 2, or it is also equal to, okay, this is also equal to t sinc of, sampling and sinc, they're related, na? Sampling x is equal to sinc x upon pi. Okay, so that will become omega t upon 2 pi. But what is omega by 2 pi? F. So this can further be written as t sinc of ft. Now what is given to you is sinc f. Okay, the xf, f domain mein, the xf is given to me as sinc of f. Okay, so what should be the xt then? Sinc of f. That means t equal to 1. If you take t equal to 1, the signal is also rect t by 1. That is rect t. The signal xt is rect t. Rect t. Acha, what is rect t signal, dear? Hey, how do you draw a rect t signal? Yahi bana dete hain. Okay, so that you compare both of them. How do you draw a rect t signal? Okay, rect t by t. Rect t by t mein the base t represents the total width. That is the standard way we define. Okay, this base t represents the total width of the signal. So what is the total width? Okay, it is equal to 1 unit here. 1 unit means symmetrically minus half to half. Minus half say half, amplitude 1. Okay. Now here also amplitude 1 say 2. So this is also rectangle having the same width. Okay, but that is centered at 1.5. Okay, or I can say 3 by 2. And this one is centered at minus 3 by 2. Okay, so when you right shift this, okay, the center will be 3 by 2. So what is this part? What is this part? This is given by x of t minus 3 by 2. Okay, and what is this? This is given by x of t plus 3 by 2. X of t minus 3 by 2, x of t plus 3 by 2. X of t minus 3 by 2, x of t plus 3 by 2. Chalo. So now we can complete this answer. What is the yt? Okay, it is given as x of t minus 3 by 2 plus the x of t plus 3 by 2. Okay, so what is going to be its Fourier transform? What is going to be its Fourier transform? Y omega, okay, x omega, time shifting property, e power minus j omega 3 by 2, e power minus j omega t naught, okay, time shifting, e power minus j omega 3 by 2, okay, plus x of omega, e raised to the power plus j omega 3 by 2. Okay, so what is y omega? Acha, whether it is exponential form या cosine के form में आएगा, we can convert to f also. Sorry, f में भी convert हो जाएगा, no issues. So x omega को common लिया, e power j theta plus e power minus j theta is 2 cos theta. Is 2 cos theta. Okay, so what is going to be yf? In terms of f, they are asking, that is going to be x of f, okay, into 2 cos omega की जगह 2 pi f. If omega is 2 pi f, so 2 से 2 will get cancelled. You will have 3 pi f. You will have 3 pi f. So 2 xf, okay, 2 xf, xf is given to as sinc f. इसको लिख देते हैं पूरा. So 2 xf is sinc f, okay, into cos 3 pi f. Into cos 3 pi f. Okay, 2 sinc f cos 3 pi f. Option number A. Dear, option number A. Correct. Option number A is completely correct. We shall be now moving to the next question. Okay, this is the number 8th. Okay, this is the number 8th. The discrete time Fourier transform of a signal is x omega equal to 1 plus cos omega e power minus j omega. Okay, consider that xpn is a periodic signal of period n equal to 4 such that, okay, xpn is equal to xn for n equal to 0, 1, 2 and it is 0 for n equal to 3. Okay, notice that xpn is, that is a Fourier series formula. So now they want to express xpn as summation k, oh sorry, it should be 0, summation 0 se n minus 1, okay, a k e power j 2 pi n by 2 pi by n kn. What is the magnitude of the Fourier series coefficient? A2. Okay. Now what is the xpn? It is equal to xn for n equal to 0, 1, 2 and it is equal to 0, ये comma लगेगा यहाँ पे, and is 0 for n equal to 3. Okay, but what is xn? xn का dtft given है. Okay, xn का dtft given है. So let me start with that dtft actually. Okay, so it's a 2 marks NAT, decent good question. Okay, what is this x omega? 1 plus cos omega, 1 plus cos omega e power minus j omega. Okay, or I can open the cos omega as e power j omega plus e power minus j omega divide by 2 whole multiplied by e power minus j omega. Now arranging the terms, okay, so ये 1 हो जाएगा, this will be minus 2 omega. Okay, so e power j omega, e power minus j omega 1. So I start with 1 by 2. Okay, then I have 1 into e power minus j omega. Okay, that is e power minus j omega. Plus again 1 by 2 e power minus j omega, that is e power minus j 2 omega. Okay, that should be the answer. Okay, that should be the x omega. Okay, now what is xn? Okay, xn is nothing but summation of xn e raised to the power minus j omega n. Okay, that is the basic DTFT formula. Okay, so e power minus j omega n. Okay, so this corresponds to e power minus j omega 1. N का value 1 है. Okay, n का value 1 है. Okay, so what is the signal xn? Okay, e power, this corresponds to e power 0. Okay, this is n equal to 0, origin pe value. Then this is 1 and then this is 1 by 2 corresponding to n equal to 2. Okay, ये इसका origin हो गया. Okay, that is the signal xn. Okay, right, that is the signal xn. Okay, so what is the signal xpn? क्या बोला था? Please pay attention. xpn will be equal to xn for n equal to 0, 1, 2. Okay, so n equal to 0, 1, 2. This 3 value will be copied, but it will be 0 for n equal to 3. 0 padding to convert it into a 4-point signal. Okay, 0 padding has been done. So xpn कितना हो गया? 1 by 2, 1 by 2 and a 0 padded to convert to a 4-point signal. We know whenever we take the length in 2 power m, okay, the FFT calculations are eased out actually. The FFT calculations are eased out. Okay, so ये xpn हो गया and I am looking for the Fourier series coefficient A2. What is the shortcut for the Fourier series coefficient A2? Okay, for the Fourier series coefficient A2. Okay, देखो A2 k is equal to 2. That is the central ordinate property. N by 2 क्योंकि total length 4 है. Okay, it is a 4-point signal. Okay, 4-point signal. The length of the signal is 4. The length of the signal is 4. Okay, and k is equal to n by 2, central ordinate, and in such case A2 is given by 1 upon n. Okay, 1 upon n. N का value 4 है. N का value 4 है into alternate plus minus. Okay, alternate plus minus. Okay, 1 by 2 minus 1 plus 1 by 2 minus 0. And that is 1 by 2 plus 1 by 2, 1 minus 1 cancelled, answer is 0. Okay, central ordinate. Okay, central ordinate in general given by 1 by n summation of the signal xp, and I am calculating the Fourier series coefficient of xpn into minus 1 ki power n. Okay, for n equal to 0 to n minus 1, and minus 1 power n, you know, okay, will be switching in sign alternatively because minus 1 power even is plus 1, minus 1 power odd is equal to minus 1 power even is 1, minus 1 power odd is minus 1. That's what it is. Okay, next question is ready for you. Okay, so now guys, before I present the next question, also keep a note of the MMC schedule. Yes, okay, the All India Open Mega Mock Test on the BYJU'S Exam Prep app are live. Okay, so you should be connected with BYJU'S Exam Prep app for multiple practice sessions. Other than this, regular practice sessions are also available. Okay, the first MMC is over. Okay, this was the date for first MMC, 14th to 20th October. So now next MMC is going to start 28th of October, and that will contain network, digital and signal and system. You can keep appearing. The result for the second MMC will come up on 4th November, and if you are performing well in this, if your name is in the toppers of the list, you can also get a chance to win huge discounts on the BYJU'S complete test series. Okay. Next question. The phase margin of a system, control system pe aa gaye. Okay, having the loop transfer function GSH is equal to 2 root 3 upon SS plus 1. Okay, 1 mark NAT, simple question. Okay, but for phase margin, what I need the omega G. What I need omega G calculation. Okay, so what is modulus of GJ omega, HJ omega? What will be the magnitude function? Dekho, 2 root 3 magnitude is 2 root 3. What will be this? S equal to J omega, magnitude is omega. 1 plus J omega. 1 plus J omega, under root 1 plus omega square. That is the magnitude. Okay, and at omega G, magnitude is 1. Gain crossover frequency, mod GJ omega, HJ omega equal to 1. Okay, so I have 2 root 3 is equal to omega square root 1 plus omega square. Yeah, if you take the square, this will be 12 equal to omega square 1 plus omega square. It will go to a fourth order polynomial. Better, what you can do is put down omega square equal to x. So 12 is equal to x into 1 plus x into x square. Okay, so now you have a simple equation to solve. X square plus x minus 12 is 0. Okay, that can be factorized as x plus 4, x minus 3. Perfect. Plus 4 minus 3 plus x aa jayega. Plus 4 into minus 3 minus 12 aa jayega. And x is equal to minus 4 and plus 3. But x is actually omega square, omega G square, and it cannot be negative. Square cannot be negative. Okay, so we will take up omega G is equal to root 3 radian per second, the gain crossover frequency. Now, one step ahead, what is the phase margin? Okay, just one step ahead. What is the phase margin? Okay, so phase margin is going to be the formula 180 degree plus phase at the omega G. So this is 1 upon J omega. Denominator hai, so we'll write down the minus phase. J omega pure imaginary. Hey, J omega is pure imaginary. See how you are going to write down the GJ omega, HJ omega. That is 2 root 3 upon J omega, S ki jagah J omega. Okay, then 1 plus S, so 1 plus J omega. Okay, and what is the phase function? Numerator the positive real number. Denominator you always write down minus. Pure imaginary 90 degree. Again minus tan inverse omega by 1. Okay, tan inverse y by x for a complex number. Okay, so minus 90 minus tan inverse omega, and omega is root 3. Okay, तो calculator का need नहीं होगा. It is 180 minus 90 tan inverse root 3. You should know 60. So 90 minus 60, 30 degree. Okay, the phase margin of the system is 30 degrees. Okay, there is something missing in the question that they should definitely mention. Okay, मैं mention कर देता हूँ because NAT question में it is very much important to mention the unit, and I have mentioned. If anybody is making the NAT question, units must be mentioned. Ki what is the units you want the answer? So I wanted degree, so it is 30 degree. Okay, agar radian mentioned hota, so that is pi by 6. So you have to check that. Okay, whatever is mentioned, I have mentioned degrees. Okay. Next question, number 10, 1 mark MSQ. One more MSQ coming up here. 1 mark means this is forced. It's a factual information. See, always remember in the exam time, you should not derive the controller and compensator general effects. Okay, so whenever you are studying controller and compensator, okay, you always have to list down their important conclusions. Okay, like you should know some straightforward conclusions about PD controller. Okay, that it improves damping, one of the very common effect. It increases zeta and the overshoot decreases. Okay, rise time and settling time also reduces. True. Okay, it is true. Okay, it reduces rise time, due to which if the rise time is reduced, bandwidth will increase. Bandwidth and rise time are inversely proportional. So ये false हो गया. Bandwidth will also increase. Rise time reduce हुआ है, bandwidth increase होगा, and because the bandwidth increases, okay, the effect of noise at higher frequency is increasing because noise is a high frequency component. So C is also correct. It increases the effect of noise at higher frequencies. Yes. It improves the gain, of course. Okay, one of the major role of the PD proportional derivative controller is to introduce a 0 in the open loop transfer function, and that will shift the root locus towards the LHP. That will improve the stability parameters, and hence in general, okay, by how much not mentioned, but in general it improves the gain margin, phase margin, and MR. okay, and the MR, the resonant peak. Why the resonant peak increases? Again, because of the increased value of zeta. Okay, so A, B, C, correct answer for this MSQ question that I've already marked. It is A and B and C. It is A and B and C. Okay, next question. Okay, 2 marks MCQ, controllability and observability. It is given that x dot is equal to 0, 1, 0, 0, 0, 1, minus 2, minus 3, minus 4, x plus 0, 0, 2, u, y equal to 1, 0, 0, x. Okay, looking into this, clearly you should be able to identify what type of model. See, it's a 3 cross 3. It's a 3 cross 3 matrix. The system matrix is 3 cross 3, means it is a third order system. For this third order, if you go and apply, okay, Kalman's test, it is going to be very lengthy. If you go and apply Kalman's test, it is actually going to be very lengthy. Okay, please make a note. It is going to be lengthy, means lengthy. Okay, so you should identify, okay, looking into this matrix, okay, if you have studied the topic thoroughly, you should be able to understand it is CCF form, controllable canonical form, and controllable form is always controllable. That is why it is named as CCF. Na? Okay, so it is always controllable. Okay, now, sir, okay, controllability done. But again, for observability, should I have to go for Kalman's test? Again, it becomes a lengthy process. Okay, no. Okay, there is also a shortcut for observability. Okay, if the system is in CCF model, that is calculate the transfer function. What is the transfer function? B, okay, into only the constant is there. Okay, that means this is 0 into S square, C0, C1, C2. This is the S square, S and constant term. Okay, plus 0 into S plus the constant term 1. Okay, divided by, okay, cubic equation hoga. Okay, and this is actually, all of them are opposite signs starting with the constant. So, ye constant hoga. If minus 2, the constant of the denominator will be 2. Reverse mein likhte hain, plus 3S, okay, plus 4S square, plus S cube. Okay. So go and see my video on state space analysis. I made long time back. I made one marathon. Okay, summarizing multiple points about state space analysis. You will understand it. It's very important to go with the preparation of CCF, OCF, JCF, and DCF form. Okay. Controllability, observability. If it is a JCF and DCF form, you should always remember the Gilbert's test. 2 marks question, 10 seconds mein solve hoga. Gilbert's test. Okay, so this is the transfer function. Okay, so let me complete the transfer function. So numerator is just 1, 2 upon S cube plus 4S square plus 3S plus 2. And then then you check for pole 0 cancellation. If there is a pole 0 cancellation, it is not observable. Okay, is there any pole 0 cancellation? Arey Baba, for 0 to cancel pole, there should be 0. Now there is no 0. Okay, there is no 0. That means there is no pole 0 cancellation. Here, there is no pole 0 cancellation. Okay, the system is observable. If there is a cancellation, then the system is unobservable. It is controllable and observable, option number A. This must be on exam. See, when we are discussing a mock test, we should try to only follow the approach which we are going to use in the exam. Okay, so I'm using the exam-based approach. Okay, I'm using the exam-based approach. Okay. Chalo. Next, number 12. Okay, find the stability of the system if it has a characteristic equation. I mean, you have to comment whether it is stable, marginally stable, conditionally stable, unstable. 2 marks MCQ question. Okay, Routh-Hurwitz. Okay, this one is taking you towards the Routh-Hurwitz. So let us go to the Routh-Array. Let us frame the Routh-Array quickly. S की power 6, S की power 5, first 2 rows. Okay, so 1, 4, 5, 2. Yeah, 1, 4, 5, 2. Be careful, check the missing coefficients if any. S power 5, so 3, and then 6, and then 3. 3 and 6 and 3 and 0. 3 and 6 and 3 and 0. S की power 4, okay, 12 minus 6, that is 6, 6 by 3, 2. 15, okay, minus 3, 12 by 3, 4. Okay, 3 into 2 divided by 3, that is 2. Last element is always 0. Okay, S cube row. Okay, S cube row पे आ जाएंगे. Okay, 12 minus 12. Okay, 0. 2 3s are 6 minus 3 to 6, 0. This will anyways be 0 because the next column in there is 0. Okay, and last element always 0. So now what do you get? You come to a ROZ condition. Okay, what do you get here? You get a ROZ, isn't it? So now, dear, if there is a row of 0, what is going to happen? Okay, if there is a row of 0, what is going to happen? Okay, so yeah, you will be talking about auxiliary equation. Let us frame the auxiliary equation to solve this. So what is my auxiliary equation? Auxiliary equation will be formed by taking the coefficients of the row which is above the row of 0. So this is going to contribute to your auxiliary equation. This is going to contribute to your auxiliary equation, and that is 2s ki power 4, okay, plus 4s square plus 2 equal to 0. Okay. Now I differentiate the auxiliary equation. We'll talk about the roots also, but let's complete the route array first. Okay, so I'm going to differentiate this. Okay, so let me differentiate this. If I differentiate this, I'll get 4 to the 8s cube plus 8s. Okay, equal to 0. And with this I will be getting what? I will be getting the modified. The corrected s power 3 row. The ROZ will be replaced with the s power 3 row with the coefficients 8 and 8. अच्छा, rather than 8 and 8 calculations को थोड़ा simple करते हैं बाबा. 8 को common ले लिया तो s cube plus s is 0 ना. You can take 8 common also and cancel it up. So ultimately it is just 1 and then 0 and then 0. अच्छा, now continue with the route array. So next will be s square row. Okay, now when you are going to the s square row, dear, okay, which row? This is not to be counted. This has been replaced by the new s power 3 row. Okay, so I have 1 into 4 minus 2, that is 4 minus 2, 2, 2 by 1 is 2. Okay, 1 into 2 divide by 1, this is 2, 0, 0. Why this is 0? Because ये 0 था ना पूरा. Last element always 0. So now the turn for s power 1 row. Okay, so 2 minus 2. Oh my god, it's again 0. Okay, this is anyway 0 क्योंकि ऊपर सब 0, 0 है. Similarly, this is 0. Last element always 0. One more ROZ. So this is ROZ1. This is ROZ2. You have the ROZ1 and ROZ2. Okay, 2 row of 0. So you might have got the idea. Achha, by the way, ROZ1 comes. System cannot be stable. Whenever auxiliary equation, whenever there is a row of 0, system cannot be stable. It may be unstable or worst case marginally stable, but cannot be stable at all. Okay, because either there will be RHP poles or either there will be J omega poles. Okay, pair of J omega poles. ठीक है, तो ये ROZ2 हो गया. Okay, so because there is the ROZ2, there will be the auxiliary equation number 2. So let it be number 1. What is the auxiliary equation number 2? That is 2s square, okay, plus 2 equal to 0. Okay, इसको कीजिए differentiate. Okay, so you have 4s and that is equal to 0. 4s that is equal to 0. Once again, I will write down the modified s power 1 row. Okay, that is simply 4s equal to 0. So 4, 0, 0, 0. Finally, s ki power 0 row. Okay, to conclude the route array, s ki power 0 row. So how much it is? 4 into 2 divided by 4. 2 and then 000. Okay, how many sign changes? No sign changes. Okay, so is the system stable? तो नहीं होगा. Okay. But I'm telling you, I'll tell you, I'll explain you also. Okay. 2 ROZs. What does it indicate? 2 ROZs indicate the possibility of repeated J omega pair. Okay. And whenever you have repeated J omega pair, the system is unstable. पहले तो आंसर को मार्क करते हैं. Okay. पहले तो आंसर को मार्क करते हैं. तो what should be the answer? It is unstable. Okay. It is unstable. Okay. Marginally stable when you have only one pair of J omega roots. Okay. Yeah, maybe 2 different pairs. That is also okay. But repeated pair of J omega root system is unstable. Conditionally stable यहाँ पे आ नहीं सकता, dear. Okay. Because conditionally stable is there when the gain parameter can be varied and based on the gain के condition on the gain के system can be made stable or unstable. Okay. तो वो तो यहाँ पे applicable ही नहीं है because the gain, okay, all the coefficients are fixed here. Okay. Now, if you want to see this possibility, na, look into the auxiliary equation, main auxiliary equation, and that is 2s power 4 plus 4s square plus 2 equal to 0. यहाँ से भी 2 cancel कर सकते थे, no problem. S power 4 plus 2s square plus 1 equal to 0, and this is nothing, dear, a plus b whole square. S square plus 1 का whole square equal to 0. S square is minus 1 repeated. So what is s? Under root of minus 1 plus minus j. Under root of minus 1 plus minus j. I told you, na, repeated J omega pair possibility. That is proved now, and system is hence unstable. Acha, why I only took the first auxiliary equation? Because whenever there are 2 auxiliary equation, the second one will always be a factor of the first one. देखो ना, 2 को common ले लो, s square plus 1. Okay. S square plus 1. It is one of the factor. It is S square plus 1 into S square plus 1. So second auxiliary equation will always be a factor of first. It is better to analyze first if you want. But you need not know. You should know these straightforward conclusions. Study RH properly. Okay, ji. So done hai. The answer is unstable. Clear. The answer is unstable. Okay. So now, okay, this was control. So how much weightage I took from signals and control? Okay, maths का मैंने बता दिया था. So from signals, I first took the weightage 1 into 1, similar to maths, plus 3 into 2, that was 7 marks, including MSQ questions were there. From the control system, I took 2 questions of 2 mark, right? 2 of 2 marks, correct, and 2 of 2 marks. Okay, that is 6 marks. Okay, that is 6 marks. Clear? Done. So let's move ahead to the next now. Okay, now, okay, some questions from electromagnetic field theory. A non-magnetic lossy dielectric material with relative permittivity 2.25 and conductivity 10 power minus 4, okay, mho per meter is applied with the electromagnetic wave, okay, of 2.5 megahertz. What is the loss tangent? Okay, a wave is traveling here applied with what? Okay, ठीक है. So what is the loss tangent? It is given by sigma divided by omega epsilon. 1 mark NAT formula question actually. Okay, sigma is 10 raised to the power minus 4. Omega 2 pi f, and f is 2.5 megahertz. 2.5 10 power 6 omega epsilon. Okay, the permittivity, relative permittivity is 2.25. So multiplied by epsilon naught, which is 8.854. 10 power minus 12. Okay, let's just do the calculations part quickly. Okay, you can also complete this, right? And then this is, okay, the numbers are turning out to be 3.195 total multiplied by, ये हो गया 10 power minus 6. Okay, 10 power minus 4 and 10 power minus 6 going above 10 power 6. Okay, so 10 power 2, so it should be 319. Okay, 319.5 approximately. It's going to be 31.19. Okay, high loss tangent. Now you might be feeling, okay, this particular material has a very low conductivity, but still it has a high loss tangent. How it is possible? Because low conductivity, okay, opposite of conductor is mostly dielectric nature. Low conductivity should represent dielectrics. But you know, that's what we discuss in electromagnetic field theory. The actual parameter to classify a material is not the conductivity, it's also the loss tangent actually. Okay, why the loss tangent is high? Because the frequency is actually very small. It's megahertz range. Okay, if you convert the same frequency to gigahertz, okay, 1000 ka difference aa jayega, and it will be then 0.3. It will be then 0.3. Then it will be a relatively low value. If you increase the frequency more, it will be low. So actual, you know, method of classifying a material is actually the loss tangent rather than the sigma. Higher loss tangent means it is a lossy medium. Okay, more characteristics of a conducting medium. Okay, then anyways, our purpose was to get the numerical value. वो आ गया है. Number 14. Two perfectly conducting infinite plane parallel sheets separated by a distance 4 meter carry uniformly distributed surface charges of equal and opposite densities 4 and minus 4 nanocoulomb per meter square respectively. Okay, if the medium between the two plates is filled with a dielectric of uniform permittivity 2 epsilon naught, then find the potential difference between the two plates. Okay, capacitor type ka configuration hai. Okay, so you can directly use the capacitor formulas, or we can just understand this. Two perfectly, okay, conducting infinite plane parallel plates are separated by a distance 4 meter. Okay, they are separated by a distance of 4 meter. Okay, one of them is having the positive charge density, one of them is having the negative. They are separated by a distance that is equal to how much? 4 meter. Okay, now let me pick up any particular point. Okay, and let's assume that this is the x direction. Any direction you can assume. Let's say this is the x direction. Okay, at this particular point here, what is the electric field? Okay, so due to a infinite plane, infinite sheet of charge, what is the electric field? Okay, we have to actually sum up, and we have to do the vector sum of both the electric fields due to the sheet 1 and sheet 2. So what is the electric field due to an infinite sheet of charge? It is given by rho s, okay, divided by 2 epsilon. Okay, rho s divided by 2 epsilon, epsilon equal to 2 epsilon naught, later on put kar denge. So rho s divided by 2 epsilon, and the electric field is always normally away from the sheet towards the point of observation. Okay, and the direction will be x here. Okay, for the first one it is ax. Plus the second, for the second one, if this is rho s, so this will be minus rho s. एक को मैंने rho s माना है. The second one is of course, that is minus rho s. So minus rho s upon 2 epsilon, same medium is there. Okay, but okay, this is also normally away from the sheet towards the point of observation, so that is actually minus ax direction. So minus minus दोनों का cancel ही होगा. Okay, it is going to be plus ax direction only. Rho s plus rho s, 2 rho s. So rho s divided by epsilon. 2 rho s upon 2 epsilon actually in the ax direction, or that is rho s upon epsilon. Okay, so what is the electric field obtained here? It is given by rho s by epsilon ax, and that is uniform field. Okay, this is a uniform field. Rho s is uniform, epsilon is uniform. Okay, so whenever you have the uniform field, the potential can be simply calculated as E into D. No need to go for the line integral, otherwise we solve the line integral of electric field, but for uniform field it is simply E into D. Okay, so now rho s ka value 4 nanocoulomb per square meter divided by epsilon, which is 2 epsilon naught, and epsilon naught is 1 upon 36 pi 10 power minus 9. देखो 8.8 10 power minus 12 भी use कर सकते हैं, 8.85 10 power minus 12, but I'm using this so that 10 power minus 9 cancel, is multiplied by the d, which is 4 meter. Correct? 4 meter, yeah. Okay, so 10 power minus 9s are cancelled. Okay, you have 4 16, 16 by 2 8, so it is 36. That will also cancel. 36 up pi divided by how much? Divided by the 36 pi is multiplied further by 8. Okay, 8 वो cancel नहीं होगा. So now let us place down the answer. How much it is turning out to be? 36 pi into 8, and this is 904.7. Okay, this is 904.7. Oh, sorry, 904.7 volts. Voltage we have from 904.7 approximately. Okay, the potential between them in the kV. चलो kV में चाहिए. Okay, so this is approximately 0.9 kV divided by 1000 to into 10 power 3. So approximately 0.9 kV. Done? Cool. So I have the next question that is coming up here. The radiation intensity of a certain antenna is u theta phi is 4 sin theta cos phi for 0 less than phi naught. Okay, 0 less than theta less than pi by 2 upper hemisphere. Okay, if the directivity of the antenna is 32 root 2, directivity is given. Which of the following is or are correct? Okay, so directivity ke liye I can start with the directive gain. Okay, for directivity I can start with the directive gain first of all. What is the directive gain formula? It is given by 4 pi. Okay, yeah, you can write it this way also. Okay, correct. It is given by 4 pi u theta phi, that is the radiation intensity, divided by the radiated power. Okay, so now dear, what is the directivity? The directivity is the maximum value of the directive gain. So maximum value will be obtained by maximizing the radiation intensity of the antenna. Okay, and what is the maximum radiation intensity of the antenna? It's a function of theta and phi. Right, it's a function of theta and phi. So maximum radiation intensity can be 1. Okay, sin theta and cos phi can be maximum 1. Okay, we'll find the values of phi naught also, but पहले ये तो solve कर ले. Okay, so what is the directivity? 32 root 2. That is equal to 4 pi u max. Okay, u max का value 4 into 1 into 1. Okay, divided by the value of P rad, and that is what we have obtained. Okay, P rad यहाँ से आ गया. The radiated power is then equal to 16 pi divided by 32 root 2, or this can be obtained as pi divided by 2 root 2. So how much will be the answer? Quicker. Yeah, 1.11. The radiated power by the antenna is 1.11 watts. Okay, and it's a MSQ question. Okay, it is the MSQ question. ध्यान देना. So 1.11 ये तो correct है. Okay, so this is wrong. And now what is the value of phi? Okay, if this was the only question, so there should be one marker. But phi, this will involve some more detailed analysis. What is the value of phi? Whether 20.7 या 40.4 या none of them. Okay, yeah, none of them. Okay, ये देखना पड़ेगा यहाँ पे हमें. Okay, so let us start evaluating it. Okay, let us start evaluating it. Okay, so we can evaluate it by the concept of radiated power. So what is the radiated power? It is given by integral in terms of radiation intensity u theta sin theta d theta d phi, u theta sin theta d theta d phi. Okay. Acha. Now if that is the case, okay, let us start integrating. So this is equal to integral u theta is 4 sin theta cos phi. Further, this is multiplied by sin theta, and then we have the d theta d phi. Okay, so now let us put down the limits, and actually it's a variable separable. Okay, theta has 0 से pi by 2, that is mentioned. Phi is 0 से phi naught, वो भी देखना पड़ेगा. So this should be how much? Sin theta, sin square theta. Okay, and I separate the variable for sin square theta को actually लिख देंगे 1 minus cos 2 theta by 2. So let me only write down 2. Integral with theta will be 1 minus cos 2 theta. 1 minus cos 2 theta d theta. Integral with phi is cos phi. Okay, that is cos phi d phi. Okay, the limit of phi is 0 से phi not unknown. The limit of theta is 0 से pi by 2. Okay, so this shall be equal to 2. Okay, now one का integral theta. Cos 2 theta का integral sin 2 theta divide by 2. 0 से pi by 2. And cos phi का integral sin phi 0 से phi naught. Cos phi का integral sin phi, that is 0 से phi naught. Okay, so now this will be equal to the 2. Okay, now upper limit ये pi by 2, but on the theta, okay, sin 2 pi by 2, sin pi 0, sin 0 also 0, theta का lower limit 0, so only limit that is left is pi by 2. And now come to the cos phi का integral, that is sin phi, and the upper limit will be sin phi naught. Okay, lower limit is 0, so this is pi sin phi naught. Okay, so dear, the radiated power which turned out to be 1.11 is pi sin phi naught. So first of all, let me write down what should be the value of sin phi naught. Okay. That should be given by 0.35 approximately. Okay, so that is 0.35. Okay, this is 0.35. So what is the value of phi naught, dear? Okay, what is the value of phi naught? Okay, so take the sine inverse of this. Okay, you are getting 20.69 or 20.7. Now there are two possibilities, 20.7 or 20.7 or, because sine theta is positive in first and second quadrant, or 180 minus 20.7. Okay, so what is the phi naught? Okay, that is 20.7. Okay, or if you subtract this, this becomes 160 or 159.3. 159.3. Okay, now what should be the correct answer for phi naught? Yeah, both can be taken. If you take phi naught as 20.7, एक fundamental problem हो जाएगा. The problem will be you have taken the U max to get to the power radiated. You have taken the U max, okay, maximum value, and you have taken the U max as 1. 4 into 1 into 1, but this 1 will only come, theta का range तो clear है. Okay, cos phi, हाँ, it can be taken, perfect है. ये phi का range है ना? Yes, 20.74 itself is correct. 20.74 itself is correct. No confusion there. ये cos phi के form में है. Sin theta is maximum theta pi by 2. Cos phi is maximum as phi, and that is included. No issues. Yes. So 20.7 is definitely a possible option. Okay. So correct answer is B as well. यहाँ पे अगर sin phi होता ना, then I think we are in trouble, because sin phi maximum value is at phi pi by 2. Okay. So okay, pi by 2 should be within the range. Okay. So this is okay. True. The correct answer is A and B. The correct answer is both A and B for this MSQ question. Okay, MSQ question. Okay, so this is the 15th question. That is from the EMFT. Okay, so if I want to tell you with respect to the EMFT, okay, with respect to the EMFT, okay, taken a smaller weightage from the EMFT. Okay, that is 1 into 1 plus 2 into 2. Not a very smaller. Already the test is small. Only the 5 marks from the EMFT, and rest 7 marks from control. Okay, 6 marks from control, 7 from digital, and sorry, digital level. I'm getting confused. So what I have done for you is, let me summarize. We have maths, then we had signals, then we had control, then we had the EMFT, maths for 7, signals for 7, control I took for 6, EMFT for 5. Just I want to remind you that I have covered 25 marks, and now what about the rest 25 marks? Now immediately Sanjay Rathi sir is joining and he'll be covering up the next 25 marks, that is the next 15 questions, okay, from digital circuits, from network theory, and from analog circuits, again important subjects. Okay, so very shortly Sanjay sir is joining, so that's it guys. From my side, and I'll share you the PDF later on. Hope you're enjoying this practice session. Hope you're enjoying your preparation for a GATE aspirant. Okay, whatever the day it is only practice and practice. That is the priority. Okay, so I invite Sanjay sir. Bye-bye from my side. Okay, see you later.
Hello everyone, this is Sanjay Rathi. Thank you Rakesh sir. Now we will continue with digital, network and analog circuit. GATE 2024, and that is mini mock test for electronics and electrical branch. This is my introduction. Myself Sanjay Rathi. I am having 23 years of teaching experience and I have trained more than 1 lakh students for these exams. And I have qualified and selected for engineering services exam. These are my ranks. AIR 16 in ESE 2005, AIR 21 in ESE 2008. This is my Telegram channel. I will upload the PDF of this session on this channel, as well as if you want notification about any exam, then you can join. That is Electronics by Sanjay Rathi. And guys, this is a scholarship test for you. And then this is workshop by Richa Gupta ma'am on 25th of October at 7:30 p.m. Now that is the first question on your screen. This is, consider the logic circuit with input signal shown in figure. All gates in the figure shown have identical non-zero delay. The signal test which was at logic low is switched to logic high and maintained at logic high. The output. Guys, these 4 gates are given. First NAND gate, inverter, 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 and that is test signal is given. And what is the position of the test signal initially? It was 0 and it will switch to 1. Means this is the case. And it will remain at high. Then, or each gate have equal delays. Then what about the output? Stay high throughout, stay low throughout, pulse from the low to high, and pulse from high to low to high. Means it will switch from high, then low, then what, high after this transition. Okay, then give me answer. This is mock test guys. Try to give me the answer for this question. Then next one, what is the answer for this one? It is 1 mark question, MCQ. There is negative marking. Now how we can solve this question? Watch this. First, because each gate has equal delay, you can write that this input is A, then this will become B, then this will become C, then this will become D. For example, each gate has delay 10 nanoseconds. We are just assuming equal delay means 10 nanoseconds we can say. Then what you can do, now this is 10 nanosecond, first line, gap is like 10 nanosecond. This is the gap between 2 lines is 10 nanosecond guys. Okay. Now, first of all, this is 0, 10, 20, 30, 40, 50 and what, 60. What was the A? This is A. Initially A was 0 and then switch to 1 exactly at t equal to 0. For example, how we can get the answer? Systematic way. Then what is the B? Inverter. Inverter means B is what? If it is 0 then it is 1. Initially it is 1. When there is a transition, let each gate has 10 nanosecond delay. Initially it is 1, then it will give the response after this transistor after 10 nanosecond and it will become 0. Then this is B. What is C? Inverter of B. Inverter. And it will give the response after 10 nanoseconds. Initially it is 1, that's why it is 0. And after 10 nanosecond it will become 1. After this transition, this delay is 10 nanosecond, this delay is 10 nanosecond. C is B bar. What is the D? C bar. Initially it is 0, that's why D is 1. And then it will give response like this. Okay. Then this is D. D is nothing but C bar. Then finally what is E? Like this is the E is the output of this. Finally we want output. Now output is a NAND gate. Initially it was 0. And what is the initial value of the D? 1. 0. Okay. So initially it was 0. It was 1. So NAND gate 0, 0, 0, 1, 1, 0, 1, 1. Remember NAND gate, this is 0, 0 is what? 1, 1, 1 and that is 0. Now initially the output is 1. At this point initially the output is 1. Now what are the inputs to the NAND gate? It depends upon A and D. A and D are the inputs. And that's why when there is A will become 1, D is also 1. Watch this. A is 1, D is 1. 1, 1, there is a transition. After 10 nanosecond, it will become 0. Because of this transition, after 10 nanosecond, it will become 0. Now we have transition in D and it is constant. Now at this point, it is 1. It is become 0. 1, 0. 1, 0 means output should be 1. After 10 nanosecond, it will become 1. So this is the actual waveform. Directly what is the answer? It will switch from high to low to high. High to low to high, and E is nothing but output. And that's why the answer for this question is pulse from high to low to high. That is the D is the answer for this one. This is the answer for this question. Next one. A number n is stored in a 4-bit 2's complement representation as A3, A2, A1, A0. It is copied into a 6-bit register, and after a few operations, the final bit pattern is same digit A3, repeated A3, A2, A1, A0, and last it will become 1. The value of this bit pattern in 2's complement representation is given in terms of original number n is. So this is n. Now you have to understand the question. First option is 32A3 2n plus 1 plus 2n plus 1, 32A3 minus 2n minus 1, and then 2n minus 1, 2n plus 1. These are the options, guys. 4 options. Now tell me which answer is correct. Read question carefully. It is a 2-mark question. MCQ means again we have negative marking here. Okay, negative marking here. 2/3 negative marking. So it is based on what? 2's complement. So take your time. Then try to solve on your scribble pad, and you have to use only virtual calculator. Now what is the answer for this one? First of all, it is a two's complement representation. Suppose you want to make it 6-digit number from 4-digit number, then you have to repeat what? MSB. So you can repeat the MSB through 2 times. So it will become A3, A3, A2, A1, A0. Okay, that will remain A3, A3, A3. Because you want to make it what? 6-digit number, then this is the same MSB repeated by 2 times, then A3, A2, A1, A0. It is the 4-bit number is converted into 2-bit, and it will remain same n. It will remain same n. Now, if it is multiplied by 2, because here it is 1 we are getting, means first of all you have to make it what? At the end you have to make it what? 0. So 0 means it is multiplied by 2. When we are multiplying it by 2, it is what? It is shifted left by 1 digit. So it will become, because it can store only the 6th digit, A2, A1, A0, and this will become 0. That is the 2n. Now, but at the end we are having the 1, means we are adding the 1 here. 1 when we are adding, it will become this number. A3, A3, A2, A1, A0, 1, and this is nothing but 2n plus 1. 2n plus 1, and that's why the answer for this question is D. D for Delhi. And that is a very, very good question from what? Number system, guys. Number system. Very, very important one. Now, next one. Then third question from multiplexer. A 4 to 1 multiplexer to realize the Boolean function x, y, z is shown in the figure below. The input y and z are connected to selectors of multiplexer y and z is y is more significant. Y and z is connected to selectors line. This is the selector line. It is visible yz. And then the canonical sum of product expression for. There are 4 options. Take a screenshot, try to solve on your rough copy and get the answer. Which answer is correct? This is the question number 18. Now, this is question on multiplexer. These are the mean terms are given. 2-mark question. Then guys, watch this. Because these are the mean terms given, so what is the function here? Y is the significant z and function is what? X, Y, Z. So X, Y, Z you can directly write. First in multiplexer you can directly write F is equal to Y bar, Z bar. It will select what? I naught. So it is, we are writing what? Y bar, Z bar, I naught plus Y bar, Z, I1 plus Y, Z bar, I2 plus Y, Z, I3. Y, Z, I3. Now what is the Y bar, I bar, X, Y naught, X? You can say X, Y bar, Z bar. First. Plus, what is the I1? 0. This means you can make it what? 0. I2. What is the I2? X bar. What is the I3? 1. And that's why it will become 1 means you can multiply with the X bar. This is X plus X bar is nothing but 1. Now, what is this function? 1, 0, 0 means 4. 1, 0, 1 means 5. And this is X bar, Y, Z. 0, 1, 1, 3. And X, Y, Z. 1, 1, 1, 7. 1, 1, 1 is what? 7, guys. So here 3, 4, 5, 7. 3, 4 or we are getting number. Please check this. Okay. So what is this number? This is the 1, 0, 0, 4. So we are having the 4 here, yes. And that is 0, 1, 0. Sorry. This is 0, 1, 0. Because of that technical problem. 0, 1, 0. This is 2. And this is 3. And this is 7. What is the number? 2, 3, 4, 7. A option. Mean term. 2, 3, 4, 7. Okay then. Next one. Now, in a digital circuit shown in the figure, the flip-flops have setup time of 5 nanosecond and a worst case delay of 15 nanoseconds. Worst case delay is what? 15 nanosecond. And then the AND gate has a delay of 5 nanosecond. This AND gate has a delay of 5 nanosecond and setup time of 5 nanosecond. Maximum possible clock rate for the circuit to operate faithfully is reliable operation. Faithfully means reliable operation. 21 megahertz, 22 megahertz, 25 megahertz, 30 megahertz. Okay. The maximum frequency of operation for reliable operation is. Then guys, in this case, what we can do, then setup time is given. Watch the diagram carefully. Again, it is a MCQ, negative marking. So be careful about that. Then how we can solve? Now, take a screenshot and try to solve, then see the answer. Okay. Then watch this diagram. This input is fixed, whether it is 1 or 0, this input is fixed. This input is also fixed. For this flip-flop and for this flip-flop, if the input are fixed, we are not changing the input. This is not a variable. Then guys, for this and for this, no need to calculate the setup time. Now for this, what is the delay in the signal? signal first of all cross this flip-flop, and that, watch this, it is a asynchronous connection. Its output will become clock for this. If the delay of this is 15, delay of this is 15, so what is the total time taken to reach up to this point? 30 nanosecond. And for this output, 15 nanosecond only, just after the clock pulse. It will take 15, it will take 30. So we have to choose the higher value, 30. And what is the delay of this gate? 5 nanosecond. Now watch this. What is the delay of the NAND gate? 5 nanosecond. So the signal will reach at this point 35 nanosecond. Okay. Now 35 nanosecond, and it should be set before. Setup time means what? If this is the clock pulse, for example, it is a positive edge triggered, then you have to set the input. You have to stable the input, or input should be stable just before occurring of the clock pulse. Okay. For how much time? This is called setup time. Before setup time, it should be stable input. And what is the setup time here? 5 nanosecond. So suppose that is the input here, input will come, and this input is let 1. So that it should be set before what? 5 nanosecond. That time is called what? Setup time. Now extra 5 nanosecond is required. So what is the total time required? 15 plus, this is the 30 plus 5, 35 plus setup time 5. So just after 40 nanosecond, you can give the next clock pulse. Then it means, what is the frequency of the clock pulse? 1 by 35 plus 5, that is the 40 nanosecond. You can write 1000 divided by 40 into 10 raised to, that is the micros, you can say minus 6. Then you can solve it. This is the 25 into 10 raised to power 6 means what? 25 megahertz. So 25 megahertz is the clock frequency. 25 megahertz is the clock frequency for this question, guys. Next one. Now these are questions from network, guys. Question from network, second subject. The source network S is connected to the load network. This is the source network. This is connected to load network. As shown by the dashed line, the power transferred from source to load would be maximum when RL is. It is based on what? Maximum power transfer theorem. So what is the RL? What should be the value of RL so that there is a maximum power transfer from this source network to what? Load network. This is 1 mark question, 0 ohm, 0.6 ohm, 0.8 ohm, 2 ohm. Okay, try to solve this question, everyone. Try to solve this question. Okay, then take your time, guys, and after solving the question, then go for solution. 0 ohm, 0.6 ohm, 0.8 ohm and 2 ohm. Then what is the maximum power transfer theorem here? This is VTH, this is RTH, and this is RL. And RL should be equal to what? RTH for maximum power. RL should be equal to RTH. Load should be equal to RTH. For example, this is load. It is load. It should be RTH. Now, what is the RTH? 2 ohm, because it is a source network, 10 volt. 10 to 2. Then what is the load current? Load current given by the source network to that load network. We can find the current here. Directly we can apply this shortcut. 10 divided by 4. That is what? 2.5 ampere, because it is given in ohm. Okay. Now this is the 2.5 ampere. 2.5 ampere current will given by source network when there is a maximum power transfer. Means again it will give the 2.5 to this network. When it will give the 2.5 ampere, so that the maximum power will be transferred to this network, then This is the 10, this is the 3. You can find the value of RL. So what is the 10 minus 3 divided by 2 plus RL is equal to 2.5. Now from this you can get, this is the 10 minus 3, 7 is equal to 2.5 into 2, 5 plus 2.5 RL. 5 minus 7 minus 5, 2. RL is equal to 2 divided by 2.5, that is nothing but 0.8 ohm. 0.8 ohm. The answer for this question is 0.8 ohm. This is the 0.8 ohm. This is the answer for this particular question. Next one. Next question, 0.8 ohm. Then guys, this is a all India open mega mock test for GATE 2024, that is for all branch civil, mechanical, electrical, electronics, computer science from 14th October to 20th October. These are the free tests. Then after that you can join the mock test. These are the regular schedule for that. Okay, for more detail you can download our BYJU'S exam prep app here and attempt now this test, right? It is a all India open mega mock test schedule for you from 14th October, then 11th of November, then 5th of November, and so on up what in the month of January, guys. So you can attempt and you can get idea about your preparation, guys. Okay, and for more detail you can join our that BYJU'S exam prep app, download and get the detail about this. Now next question, again from the network, 1 marks. The average power delivered to an impedance 4 minus J3 by the current 5 cos of 100 pi t 100 ampere. That is directly current is given. Average power means effective power. What is the effective power delivered to an impedance? It is a 4 minus J3, means it is a complex impedance. That is what this is. The minus means definitely it is capacitive in nature, and this is the 4 means resistive. Then what is the power, average power delivered to this? 44.2, 50 watt, 62.5, 125 watt. Then what is the average power? Yes, please. Then remember, use your rough copy, try to solve and then see the solution. S complex power is given by I RMS square R, this is the impedance, Z. What is the RMS value of the current? 5 by root 2 square. What is the impedance? 4 minus J3. Okay, then it will become 25 by 2 into 4 minus 25 by 2, this is the 25 by 2 into 3, and this is nothing but P plus JQ. Now this P is called average power. So what is the average power? This is 25 into 4, that is what 50 watt, and that is what reactive power. Reactive power, guys. Okay, because it is a capacitive circuit, means it is a leading circuit. So what is the answer for this question? 50 watt. Answer for this question is 50 watt. And next, for the circuit shown below, the input resistance is R11 is equal to V1 by I1 with I2 is equal to 0 is. V1 by I1 with I2 0 means it is nothing but Z11. Nothing but Z11. Here it is given R11, 2-port network. Then the answer given is minus 3, 2, 3 and 13 ohm. Which is the answer? Which answer is correct? Minus 3, 2, 3 and 13 ohm. And that is 2-port network, it is given here. Then tell me everyone, what is the answer for this one? Yes, please. Then I2. Give me answer in comments box. This is a two-port network. You have to make the I2 0. Then. And what is the V1 by I1? Now check your answer. I think you have drawn the diagram. Try to solve with me. Then this is I1. This is I2 is 0. When we are making the I2 0, this will become 0. Means this is the short circuit. Voltage source will become short circuit. Then what is the current at this node? I1. What is the current at this node? 2V3. What is the current here? I1 plus 2V3. Same current will flow because it is I2 is 0. There is no current. What is the current here? I1 plus 2V3. Now, at this node, what is the incoming current? I1 plus 2V3. What is the outgoing? 2V3. So, I1 plus 2V3 minus 2V3. What is the current here? I1 only. Now, directly you will get the relation between V3 and I1. So, what is the V3 is equal to 2 times of I1. This is the first equation. Now, second equation, you can write a KVL here. You can write a KVL in this loop. From this point to this point to this one. So what is the KVL here? V1 is equal to I1, 1 into I1 plus 0, 2 times of I1 plus 2V3, and this is plus V3. Okay, KVL is over. Then you can write 2 plus 1, 3 I1 plus 2 into 2, 4, 5 V3. Equation number 2. Then what is the I1? V3, 2 I1. So you can write 2 I1. So it will become 3 I1 plus 10 I1. So what is the V1 by I1? 13 ohm. And that is called R11. Answer for this question is 13 ohm. 13 ohm. This is a 2-mark question from 2-port network. 13 ohm. So don't worry about what dependent sources, this and that. Okay, because once we are making the I2 0, one dependent source is short circuited, and use the KCL KVL on the same diagram, and then you can find the value here. 13 ohm is the answer. Next one. This is a question from transient. In the circuit shown in the figure, initially the capacitor is uncharged. The switch S is closed at t equal to 0. Uncharged means there is no voltage across the capacitor. Switch is closed at t equal to 0. You can close the switch. After 2 milliseconds, that is 2 milliseconds after the switch is closed, the current through the capacitor is. What is the current through the capacitor? You have to find. Okay, current through the capacitor. Now, give effort. Try to solve this question. Use your rough copy and pen and calculator, guys. This is mock test. Okay, done. Done, guys. Okay, then. Now, in the circuit shown in the figure, switch is closed and initial voltage across the capacitor is 0. You have to find the current through the capacitor after 2 milliseconds. What we can do, first of all, remember, Vc 0 negative is equal to Vc 0 positive is equal to 0. Initially it is unenergized and capacitor does not allow sudden change of voltage. Now final voltage exactly at t equal to infinite, final voltage exactly at t equal to infinity, capacitor act as what? Open circuit. Capacitor act as open circuit. So when we are making the capacitor open circuit, what is the final voltage across the capacitor? Now this is 2 kilo ohm, this is 2 kilo ohm, this is 5 volt. The final voltage will become 2 divided by 5, 2 plus 2 into 2, voltage division rule, and it will become 2.5. The final voltage is 2.5 volt, and what is the final value of the current? 0. What is the final value of the current? 0. And what is the initial value of the current? Initially capacitor act as short circuit. Initially capacitor act as short circuit, and that's why the initial value of, because it is short circuit, it will short circuit the 2 kilo ohm resistor. What is the voltage at this point? 0. Then 5 minus 0 by 2, what is the initial current? 2.5 milliampere. 2.5 milliampere, 5 minus 2, and that will pass through the capacitor. What is the initial current through the capacitor? 2 milliampere. 2.5 milliampere. Now you have the initial voltage, initial current, everything. Now what is the time constant? How we can find the time constant of the circuit? Time constant is what? RC, R equivalent into C. R equivalent means RTS, Thevenin's resistance. So remove the capacitor and make the voltage source 0. Make this source 0. 2 kilo ohm in parallel. So what is the Thevenin's resistance across the capacitor? That is 2 parallel with 2, 1 kilo. And therefore, what is the time constant? What is the value of the C? 4 microfarad. RC, it is in kilo, 10 to the power 3, 4 into 10 to the power minus 6. It will become 4 into 10 to the power minus 3 second. 4 into 10 to the power minus 3 second, or 4 millisecond. Okay. Now, for this diagram, you have initial value of the capacitor, final value of the capacitor. What? Write like this. What is the voltage across the capacitor at t equal to 0, at t equal to infinite, and what is the time constant? Initial value 0, final value 2.5 volt, and what is the time constant? Time constant was 4 millisecond. Okay. Now what is the value of the current? Initial value of the current, already I have taken a short circuit, 5 by 2. So what was the initial value of the current? 2.5 ampere. What is the final value of the current? 0. This is the 2.5 ampere, 0. And what is again the time constant? 4 milliseconds. Now you can write two equations. First, what is the voltage across the capacitor? V final minus V final minus V initial e raised to power minus t by tau. Then it will become V final. What is the V final? 2.5 volt. V final 2.5. V initial 0. E raised to power minus t by tau. What is the tau? Remember 4 millisecond. It is in millisecond. 4 into 10 raised to power minus 3. It is in second now. Now it will become guys, Vc is equal to 2.5. You can take common, 1 minus e raised to power 1000 divided by 4, 250 into t. And that is the voltage across the capacitor in volt. Now, similarly, you can find the current also. What is the IC? I final. You can use the same formula. I final, I initial, e raised to power minus t by tau. What is the final value? 0. What is the final value? 0. What is the initial value? 2.5 e raised to power minus t by 4 into 10 raised to power minus 3. And you will get IC is equal to 2.5 e raised to power minus 250 t. That is the current through the capacitor. So what is the voltage across the capacitor? Vc is equal to, watch this, Vc is equal to 2.5 1 minus e raised to power minus 250 into t. Some student will ask, sir, IC is equal to what? C dVc by dt. You will get the same answer. What is the IC? C, 4 microfarad, 4 into 10 raised to power minus 6. Now what is the differentiation of this into 2.5? Directly I am doing the differentiation 2.5, and what is the differentiation of this? Minus minus it will become plus 250. This will become what? 250 e raised to power minus 250 into t. Now watch this. Again, when we are solving this, that is, this is in what? Milliampere, remember. This is in what? Milliampere. Now when we are using, this is the when we are differentiating, this is multiplied here. Please watch multiplication here. 2.5 into 4, then into 250. Okay, then arrange it, because already we have what we have done. We have done this values. Okay, 1 minute. That is the time in what? Millisecond, and this is the microfarad. It is given 4 into 10 raised to power minus 6. You can convert it into what? Millifarad. Then finally you will get this answer. 2.5 e raised to power minus 250 t. Okay, but remember one thing, that current is in what? What is the final current? Please check the unit also. What is the unit here? Vc is what? 4 millisecond. IC is what? 4 mil. That is the time constant. And 2.5 is not ampere. It is not in ampere. It is in what? Milliampere. So V final 2.5, V final 2.5, V initial 0, e raised to power minus t by 4 into 10 raised to power 4. That is in volt. 2.5 into 1 minus e raised to power minus 250 t, that is the voltage across the capacitor. Always remember, voltage across the capacitor, guys. Now there are two ways to find the current. First way to find the current is this equation. So what is the final current? What is the final current? What is the initial current? And I have written the same. Yes, what is the time constant? 4 millisecond. Yes, that is correct. 4 into 10 raised to power minus 3. And that will become what? Okay, 1000 divided by 4. What? 1 minute. 1000 divided by 4, that is what? 250 e raised to power minus t. Perfect. This is the IC. Then Vc, or second formula, Vc is equal to 2.5 1 minus e raised to power minus 250 t. Then C dVc by dt means what is the value of the C here? 4 microfarad. So you will write the 4 microfarad means 4 into 10 raised to power minus 6 into, that is in volt. Okay, right now this is because it is in volt. So 2.5, this is perfect. 2.5 into 4, you are multiply with the 250, you will find 2.5 e raised to power minus 250 into 10 raised to power minus 3. (250t). Perfect. This is in ampere. This is in what? Ampere. And this equation is in what? Milliampere, because 2.5 it is in milliampere. So what is the milliampere? 2.5. You will get the same answer. 250t. Okay. What is this? What we are doing? First of all, get the equation. Now we want the current at what? 2 milliseconds. So 2.5 e raised to power minus 250 into 2 milliseconds. This is already, it is the 2 milliseconds means what? 2 into 10 raised to power minus 3. 2 into 10 raised to power minus 3 means 500 into 0.5. So 2.5 e raised to power minus 0.5, that is your answer. That is your answer. Use your calculator and find the value. Into 2.5. And answer is 1.516. 1.516 milliampere. So what I want to say that no need to use the C dVc by dt. Directly you can find the formula from this equation, guys. I final minus I initial e raised to power minus t by tau. Directly use this equation. No need to use this C dVc by dt here. Okay then. Then the linear IV characteristics of the two terminal non-ideal DC sources X and Y are shown in the figure. This is the X and this is Y. Connected to a 1 ohm resistor as shown. The current through the resistor in ampere is. What is the current through the resistor in ampere is? You have to find it. Okay. Then these two sources are given. Try to solve this question and what will be the answer? It is a 2-mark question. This line is one source. This is the source X and this is the source Y. Source X and source Y. And you have to connect them, means you have to find the value of the VTH and value of the RTH, because any source has VTH and RTH. What is the value? And then connect and then you can find the current. Read question carefully. Linear IV characteristics of two terminal non-ideal DC sources X and Y are shown in the figure. If the sources are connected to 1 ohm resistor, the current through the resistor in ampere is. For any source, always remember this is voltage. Open circuit voltage means when there is no current. So what is the open circuit voltage? 4 volt. For example, it is any source. That is the Vx. Vx is what? Open circuit voltage is 4 volt. And what is the open circuit voltage for this diagram? 4 volt. That's why this is the 4 volt. Directly you can see that that is the value. Second thing, short circuit current, the maximum current when the voltage is 0. That is RTH. This is the VTH. That's why the maximum current is VTH upon RTH. And that is in first case when we are talking about the source as it is given as 2. So first you can find the VTH, that is the value is 4, and from VTH upon RTH, that is 2. So what is the RTH? RTH is equal to VTH upon 2. 4 by 2, that is what? 2 ohm. So X source is 4 volt 2 ohm. We will connect. Then what is the source Y? Watch this source Y. This is Y. Y is 3. This is 3. And that is what? 3 also. So what is the open circuit voltage? VTH 3. And that is the VTH by RTH. It is also what? 3. So what is the RTH? 1. RTH is what? 1. Now we have 3 volt 1. We have 4 volt 2. Now connect. Then you can connect. Four volt 2, 3 volt 1, and 1 ohm is connected here. Now, what is the value of the current then? 4 plus 3 7, 2 plus 1 4. 7 by 4, and that is nothing but 1.75 ampere, because if it is our ohm, then it is in ampere. That is the answer. Answer for this question is 1.75 ampere. 2-mark question, MCQ. Sorry, it is a numerical answer type question. NAT. Numerical answer type question, guys. Next one. Now question from analog. Next 6 questions from analog, guys. First question. the peak value of the output voltage V0 across the capacitor shown in the figure for 230:9, that is the turn ratio of the transformer, and a 230 volt 50 hertz. Now read question and according to you solve. Input, assuming 0.7 volt diode drop, means these diodes are practical diode, and that is what bridge rectifier with capacitor filter. An ideal transformer is 12.73, 11.33, 7.6 and 9.0. Then try to solve this question. Okay. Now watch this. This is a nothing but a bridge rectifier with capacitor filter. Now this is always remember 230 volt is what? RMS value. So what is the peak value? 230 root 2. What is the peak value here? This is the, on the this side the peak value is given by 230 into root 2. What is the Vp by Vm? This will become 230 by 9. That is the turn ratio 230 by 9. So what is the Vm is equal to? Vm will become 9 upon 230 into Vp. Now 9 upon 230 into 230 root 2. This is the peak value on the primary side because it is the RMS value. This is the RMS value. And that is the peak value 230 into root 2. This 230 cancel and you will get 9 root 2 is the peak value. Now 9 root 2 is the peak value at this point. If the diodes are ideal, then the capacitor will charge up to what Vm. Then that will be the output. But these diodes are practical. And in a bridge rectifier, two diodes are conducted in series. Then we have to subtract the drop across the diode. So capacitor, what is the maximum voltage across the capacitor? That is the output voltage is maximum input voltage on the secondary side minus 2 drop across the diode. It will become 9 root 2 minus 2 into 0.7, 1.4 and you will get 11.33 volt. 11.33 nearly equal to, okay. And if it is diodes are ideal, then you will get 9 root 2. The number of students are giving this answer, but this is wrong, this is correct. Because these are the practical diodes. And capacitor filter, because no RL is connected. If the no RL is connected, the capacitor will charge up to what? Maximum possible value. Maximum possible value. Okay then. Then that is the answer. Now next. Guys, you can download the BYJU'S exam prep app from our Google Play Store, and this is the mock test. You will get the idea about the leaderboard, how many number of students participated here, and what is your scorecard, each and everything in our mock test. And number of mock tests are available, free tests are available. You can join now. Right? Okay then. Next one. Next question from again operational amplifier. For the op-amp shown in the figure, the bias currents are 350 nanoampere, one, and second one is 450 nanoampere. The values of the input bias current and input offset currents. This is the formula based question, 1 mark question. Input bias current and input offset current. Input bias current and input offset current. Now try to solve this one. Remember, input bias current is average value of these two. So what is the average value of 350 plus 450 upon 2? That is nothing but 400 nanoampere. And what is the offset current? Difference of these two. 450 magnitude of that. offset current is, this is the magnitude of that, 453, that will become what is the magnitude of this? Positive 100 nanoampere. 400 nanoampere average value, and difference is offset current. So what is the difference of 350 and 450? 100, and what is the average? 400, and that's why this is the B. Bias current, offset current. No, this is no. This is D is the answer. Bias current and offset current. Bias 100 nanoampere and 400 nanoampere. 1 mark question. Next one. The value of V0 of the series regulator. Series means that this transistor is connected in series with the RL, and that's why it is called series voltage regulator. Then tell me, what is the output voltage, guys? Okay, 24 volt, 28 volt, 30 volt, 32 volt. It is 8 kilo ohm resistor is connected, 2 kilo ohm resistor is connected. It is a 2 mark question, MCQ. There is 2/3 negative marking. And what will be the answer? Value of V0 of the series regulator shown below is try to solve this question and give me answer in comments box. (24 volt, 28 volt, 30 volt, 32 volt). Now watch this. Now give me the answer in comments box. You can continue with rough copy and your calculator. Now watch. In this, transistor will be in active region, and operational amplifier is with negative feedback. That's why the virtual short concept is valid. This is the VP, this is the VN. So VN and VP are equal. That's why this is 6 volt. And what is the current enter into the operational amplifier? 0. Now this is 6 volt. So from this point to this point, it is 6 volt. So what is the voltage at this point? This is the VN. According to voltage divider, 2 plus 8. 2 upon 2 plus 8 into V0. That is the value of Vn. And what is the value of the Vn? 6 volt. What is the value of the V0? 6 into 10. This is the 8 into 2, 10 upon 2. That is 60 by 2. Means what is the output voltage? 30 volt. What is the output voltage? 30 volt, guys. Okay. So answer is 30 volt. Very, very simple question. Virtual short concept you can use. This is the C. Output regulated voltage is 30 volt. And the drop across the transistor is VC, because it is in series, that is 10 volt. Unregulated voltage minus regulated voltage, that is the called 10 volt. Okay. And if we are increasing the input, the excess voltage will come across the transistor. That is a voltage regulator, series voltage regulator. Okay. So 30 volt is the answer. Now, in the circuit shown, the Zener diode has ideal characteristics and a breakdown voltage of 3.2 volt. Breakdown voltage for the Zener diode is 3.2 volt. The output voltage V0 for an input voltage of 1 volt. Here we are giving the input voltage 1 volt. It is connected to inverting terminal, and that's why all the answers are negative. All the answers are negative because it is a 180-degree phase shift. 10 kilo ohm, 10 kilo ohm Zener diode is connected here. Now what is the correct answer? Minus 10 volt, minus 6.6 volt, minus 5 volt, minus 3.2 volt. Tell me. Remember, in this question, first of all, you can assume let Zener diode is off. Diode is off. Why off? Because when we are giving the positive voltage here, definitely it will be negative. And because of this negative, that diode is maybe reverse bias. So you can make it what off. Just make it off. Make it open circuit. Make it what open circuit. Okay. Now, once you have made it what open circuit, then what is the gain? Simple. V0 will become minus RF. This is the minus RF by R1 into 1. That is the minus 10 volt. Now here you are having the minus 10 volt. Virtual short concept. This is the 0 volt. Now what is the drop across the diode? Watch this. This is minus 10 volt because this is minus 10 volt. And what is the current through the 10 kilo ohm? 0. This is the 0 volt. So actually the drop across the diode in reverse direction, it will become 10 volt. In reverse direction, it will become what? 10 volt. It is reverse bias by 10 volt, and that is more than its breakdown voltage 3.2 volt. Means that is not reverse bias, and that's why the output is not minus 10 volt. It is breakdown and it will allow the current. It is on. So that is the wrong our assumption. This assumption is wrong. First one. Then second. Now when this diode is in breakdown region, the voltage across the diode is fixed 3.2. That is voltage drop across the diode. It is a 3.2 volt breakdown voltage. When what is the output then? Very, very simple. Because of this path, it is a negative feedback. The virtual short concept. This is 0. This is 0. Vp is equal to Vn. You can apply the KCL at this point. So you can write 0 minus Vi upon 1. What is the Vi directly applied? What is the Vi? 1 volt. 0 minus 1 upon 1. 0 minus 1 upon 1 because it is 1 given. 0 minus V0 upon 10. This is 0 minus V0 upon 10. And what is the voltage at this point? 3.2 plus V0. You can write 0 minus 3.2 plus V0 upon 10 is equal to 0. This is always remember. At this point, this is a drop 3.2 plus V0, and that's why 0 minus 3.2 plus V0 upon 10. Now you can take 10 as a LCM. It will become minus 10 minus V0. This is the minus V0. Minus 3.2 minus V0 is equal to 0. Then this 10 will become 0. This will become 2 V0 is equal to minus 13.2. So what is the V0 is equal to minus 13.2 divided by 2. Now you can find the value 6.6. Very, very simple. KCL in operational amplifier, you can trust on what KCL, Kirchhoff's current law. Directly at this point, apply the KCL. 6 minus 6.6, negative value. All are negative answer, minus 6.6. 2 mark question. Now next. Okay, transistor. In the circuit shown below, VB is 0.7 volt. Beta of the transistor and VCE are respectively. Beta of the transistor and VCE are respectively. So what is given here? Now try to solve this question, everyone. Last two question guys, 29 and 30. It is a mini mock test for you. And enjoy the Dashera. Happy Dashera everyone. Now this is a festival time. After Dashera then Deepavali. But you have to continue with your study guys. जितना ज़्यादा आपसे मॉक टेस्ट हो सके आप देते रहिए और आप क्वेश्चन प्रैक्टिस करते रहिए. डिफरेंट क्वेश्चंस हम भी आप लोगों के लिए लेकर आते रहेंगे. सब्सक्राइब द चैनल. इन द सर्किट शोन बिलो VB 0.7, the beta of the transistor and VCE are respectively. Take a screenshot. First of all, draw the diagram on your copy. And then it is Zener diode. Because there is a current through the Zener diode means already it is in breakdown. And then so value of beta is required as well as value of VCE is required. Okay, value of beta and value of VCE. Now, how we can solve this question? Remember, this is 0.7 volt VB. It is given in the question. Now, this is the 6 volt fixed. So you can find the current here. If you can find the current here, it means you can find the IB here. Okay. Now, because what is the IB? I1 minus general diode current 0.5 milliampere. Then you can find the IB. Then what is the IE? This voltage, VE. 6 minus 0.7 means it is 5.3. 6 minus 0.7 means it is 5.3. So what is the value of IE? This is the 0.53 kilo ohm. It is in ohm means 0.53 kilo ohm. IE will become 5.3 divided by 0.53 means it is a 10 milliampere. 10 milliampere I. Then what is the IE? IE is equal to 1 plus beta times of IB. Now, from this IE is known, if IB is known, then you can find the value of beta. That is the approach. Now, first of all, find the value of I1. I1 is equal to 10 minus 6 by 4. And you will get I1 is equal to 1 milliampere. Very simple calculation without calculator. Then IB. IB is I1 minus IZ. I1 minus IZ. 1 minus 0.5. Then IB will become what? 0.5 milliampere. Now, from this formula, what is the 1 plus beta is equal to? 1 plus beta is equal to IE upon IB. IE is 10 upon 0.5. Then it will become what? 20. So what is the beta is equal to? 19. 20 minus 1, that is the 19. Now you got the value of the beta. What is the value of the beta? 19. So which answers are correct? Maybe A or B. Now what is the value of VCE? What is the value of VCE? Now, watch this diagram. Now you have the value of IE 10 milliampere. This voltage is what? Already you have the, with respect to ground, this voltage is what? 5.3 volt. Already we have calculated. Now if you have this voltage VC, then VCE is nothing but VC minus VE. Now what is the VC? So what is the IC current here? And that is the 0.2 kilo ohm. So IC is nothing but beta times of IB. Beta is 19, IB is 0.5. Right? Then you can say 19 into, what is the 19 into 0.5? 9.5. 9.5 milliampere, that is the value of IC. So what is the value of the VC here? VC will become VCC minus ICRC. What is the VCC? 10 volt. IC 9.5 into 0.2. Then please calculate it. 9.5 into 0.2. You will get 8.1 volt. This is the value of VC, not VCE. VC 8.1, 5.3. Then what is the value of the VCE? From this 8.1 minus 5.3. You will get 2.8 volt. And that is greater than what? Saturation voltage, and that's why it is in active region. So 2.8 volt is the VC. You can also apply the KVL here. No? You can also apply the KVL from this point to this point. Directly 10 is equal to IC into 0.2 plus VC plus what? 0.53 into IE. Again you will get the same answer. That is a two way to solve the VC, and that is the answer for this question is 2.8 volt. Which is the correct answer? A is the correct answer. A is the correct answer for this question. Last question guys, 30th question for mini mock test. In the amplifier circuit shown below, that is the amplifier circuit, assume VB is 0.7. VB is what? 0.7. Beta of the transistor and the values of C1 and C2 are extremely high. These are the coupling capacitor. Normally we are taking coupling capacitor very, very high. If the amplifier is designed such that at Quotient point, it's VCE is equal to VCC by 2. VCE is equal to what? VCC by 2. Where VCC is the power supply voltage, its small signal voltage gain is. What is the small signal voltage gain? RC is not given, RE is not given, and a voltage gain is required. Then how we can find the voltage gain here? Okay, now try to understand. Then guys, how we can find the voltage gain here? Small signal voltage gain, as you know. Now please try to solve first of all. This is a mock test. Take your time, 1 minute. Draw the diagram on your copy. Okay. Give me the answer in comments box now, everyone. This is a common emitter with RE. This is a common emitter with RE. With unbypassed RE. And the approximated gain for this AVS, that is the V naught by Vn, is minus RC by RE. Approximated gain. Means you have to find the ratio of RC by RE. And magnitude will become RC by RE. And then from the DC analysis, what we can do, how we can find the RC by RE? First of all, make this capacitor open circuit. Then you can remove this capacitor. You can remove this capacitor because under DC analysis, this will act as open circuit. Very first work. Then second work is what? Apply Thevenin's from this point to this point. Cut this point. What is the drop across the 1.2 kilo ohm? Drop across the 1.2 kilo ohm is VTH 1.2 divided by 1.2 plus 8.8. This is the R1, R2 upon R1 plus R2 into 10. Then it will become 1.2 volt. Drop at this point is 1.2 volt. No need to find the RTH, that is R1 parallel with R2, because beta is very, very large and base current is 0. Then finally, this diagram is converted into this one. This is RE, this is RC, this is VCC 10 volt. No need to find the RTH because there is no drop. Base current is 0. You have find this 1.2. This is 0.7 volt VBE, 1.2 volt. Now, what is the IB0? So, what is the voltage at this point? That is the VE. And the same current will pass from this point to this point. Why? Because IB is 0. Now, what is the voltage? 1.2 minus 0.7. 1.2 minus 0.7 is 0.5 volt. This voltage is 0.5 volt. And guys, what is the VCE is given? VCE is given VCC by 2. VCC by 2 means 5 volt. It is given in the question. It is given in the question 5 volt. VCE. This is given. VCC by 2, 5 volt. Then if it is 5 volt, it is 0.5 volt. So what is the VC with respect to ground? V, this plus this. So it will become 5.5 volt. Now, if this is 5.5 volt, what is the drop across the RC? Exactly, the drop across the RC is 10 minus 5.5. That is what? 4.5 volt. This is the drop across the RC and that is the drop across the RE 0.5. Now, if you have the drop across the RC, what is the ICRC? And what is the drop across the RE? IERE. Divide these two, ICRC and IERE. This is the ICRE. This is nothing but 4.5 and this is given as 0.5 and you will get the answer 9. IC cancel. What is the ratio of RC by RE? RC by RE will become 9. Why we are finding the RC by RE? Because RC by RE is the gain. RC by RE is the gain, and then that's why the answer for this question is 9. Answer for this question is what? 9. Okay. So that is the mock test, guys. Hope you have enjoyed the session. Then finally, this is, we are taking what? Crash course for you, complete syllabus coverage, live classes, recorded lectures, mock test, study material, practice quizzes, and that is for what? Electronics branch as well as for electrical branch. For more detail, you can call at this number and you can install what? BYJU'S exam prep from Google Play Store. Thank you for attending the session. For PDF of this session, this is my Telegram channel, that is Electronics by Sanjay Rathi. Okay then, happy Dashera again. Enjoy your day and give mock test as much as possible. Thank you. Like the session, subscribe our channel and share the link of this session. Thank you.